Welcome to Rational Expressions and Equations, lesson number 7. In this lesson, we're going to talk about rational equations. So what we were looking at before was rational expressions, multiplying, dividing, adding, subtracting, and now we're going to move on to working with the equations. Okay, so a rational equation is an equation in which at least one of the terms is a rational expression with a variable in the denominator. Okay, so it's going to look like something that we've been working with. Now, let's look at how we would solve these questions by graphing, first of all. Okay, so to solve the equation 3 divided by x plus 1 plus 1 divided by x minus 1 equal 2, by the intersection method, use the following procedure. So the first thing we're going to do is put this into our graphing calculators. Now, when you're putting this into your graphing calculator, this is when you really want to be careful with where you're using brackets. So I'm going to start by putting this into my y1, and I want to use a bracket here. So 3 divided by this bottom term, and with this bottom term I also want to use a bracket and have x plus 1 and then close that bracket and then close it again, because what that is saying is I'm dividing this term by this. Okay, and now what I want to do is I want to add that next term. So plus bracket 1 divided by bracket x minus 1. And then I want to close that with another bracket. Okay, now for my y2 value, I'm going to put in 2. And it says to choose an appropriate window which shows all the intersection points. And in this case, it gives us our window settings. And so our window settings here are going to be -5, -5, 5, and 1, and same thing, -5, 5, and 1. And I'm going to graph that. Okay, so this is a graph that you may not have seen before, probably haven't. Now, with your TI-84 Plus, this is what the graph is going to look like. So that's a newer model of this one here. If you're using this model, the TI-83 Plus, your graph is going to look something like this. Okay, so if this is what you're seeing, do not be alarmed. These are actually the same thing. Now the only difference here is I haven't adjusted the window settings. So that's going to be -5, that was 5, 1, that was -5, 5, and 1. Now it's still going to look a little bit different. It just supplies these lines, and all these are going to be the dotted lines showing you where this middle term is not approaching. Okay, so if you have either one of these graphing calculators, this is what the differences are going to look like. Okay, so the next thing we want to do is find the x-coordinates on this graph. Now we're going to do that by using the intersect feature on the graphing calculator. And if we're using the intersect feature, we're looking at where it's crossing that line on 2. Okay, so choose option 5 here. And the first thing we're going to do is look at this first curve, this one going down here. And we're crossing this line at 2. And so I'm just going to place it there. And I'm going to guess where it's going to cross. And it looks like it's at, oh, that's not right. It looks like it should be at 0. And maybe I'll put it over, I'll guess over here. I'm just going to guess right there. Yeah, and my intersection is at 0. So I know that one of my x values is going to be 0. And the other one looks like it's going to be crossing at 2, but let's double check that. And we'll put the second curve over here. And we are at x is equal to 2. Okay, so that's how we use our intersection method. Now what we want to do is transpose this graph onto our grid here. So it's going to look something like this. Now if you're using this calculator, it's actually kind of handy because it supplies us with these lines already. So that's pretty helpful in actually trying our other graph, or drawing this onto some paper. And so what this is going to look like is we have a graph going through well, this should be at 2 right here. If we have our graph going through our value at 2, and this one extending up and down, we also have it going through 2 on our axis there. Okay, so this is our point 0 and 2. And that was where our lines cross at our x-axis. Now let's look at the next method of solving these types of questions. And that's the x-intercept method. So the other one was the intersection method. This is the x-intercept method. Now, to solve this equation using this method, it's very similar. The only difference is we want to rearrange the original equation so we have all the terms on one side and then we have it equal to 0. So all we did is, because we were at 2 on this side, if we subtract 2 from both sides, we're going to be left with our rational expression and then subtract 2. Now, the only difference here is when we're putting this into our graphing calculator, this is going to, instead of having 2 on my y2, I'm going to make this all one expression and then subtract 2, just like we did up here. And then I'll graph that, and you'll see there's a little bit of a difference. Our graph has shifted down where we're crossing the y-axis, and so this was the original that we used earlier, and this is what our graph looks like now. Okay, so let's first of all draw what this is going to look like. This was the same, this line was the same, but the only difference is now it's crossing exactly at our origin, and we're crossing below, and it looks like we're still at 2. All right, so I know that even if I use my 0 feature on my calculator, that's what it's going to tell me, that we're at. So the first one, it's just like we were doing before when we were looking for the x values on a quadratic function. It's going to tell us what our zeros are. And so I know that x is equal to 0, and I know that x is equal to 2 over here. And so I actually have to go all the way down so I end up over here, see? And I have to do the same thing, and I have to guess where I am right bound and left bound, and then put my guess, and that x is equal to 2 again. Alright, so those are two different methods, the intersection method and the x-intercept method. Both ways will help you determine where your graph is actually crossing. Now, I kind of overshot here. This should be going more along that line. Okay, so the next step is to solve these rational equations algebraically. Okay, now when we're solving these algebraically, there are a few steps that we do need to follow just to make things easier. Now, the first thing you need to do is, if the equation consists of a single rational expression on each side, then use cross multiplication to simplify the equation. So that would be like this one down here. All right, that's what we're going to do, is use cross multiplication. If the rational equation has more than one term on either side, for example, this one here, consider multiplying each term in the equation by the lowest common multiple of the denominators. So this would be x. We would multiply both sides by x. Then use previously learned skills for solving linear or radical or quadratic equations. So we want to balance both sides out to solve for x. And then always be aware there are domain restrictions when dealing with rational functions. And so you're going to have to verify which solutions are going to work, and also note that the solution cannot be a non-permissible value. So in this case, our non-permissible value would be 0 because of our x's, and over here we would have our non-permissible values of -1 and -2, because that would result in dividing by 0. Okay, so let's look at this first one. In each case, state the non-permissible values and solve the equation algebraically. Well, just like we read earlier, if the rational equation has more than one term, so I have my rational expression here, but there's an extra term on both sides, then we have to multiply each term by the lowest common multiple of the denominators. So in this case, we have to multiply both sides by x. And let's state our restriction right away. X cannot equal 0. Okay, so I'm going to multiply by x on both sides. So if I multiply both sides by x, my x's on the bottom are going to cancel out, and I'm going to be left with 4x plus 2, because the x's cancel on the bottom, and we're going to multiply that term on the top. And then and the same thing on this side, we'll be left with 4x plus 2 is equal to 7x plus 3, because those x's canceled out. And then we have to solve for x by bringing all our terms, our like terms, together. So if I subtract 4x from this side, I'll have to subtract 4x from this side as well, and I'll be left with 2 is equal to 3x plus 3. But then I have to get rid of this 3 by subtracting it on both sides, and I'm going to have negative 1 is equal to 3x. And I have to solve for x, and so I'm going to get x is equal to negative 1/3. I did that by dividing by 3. Okay, and so I know that x cannot equal 0. This does not equal 0, so it looks like we're good. But just to be sure, let's verify. So my left side was 4 plus 2 divided by negative 1/3, and that is going to be equal to 4. It's going to be 2 times negative 3 is going to be negative 6, so that gives us negative 2 as an answer. Now let's see if our right side is equal. My right side is equal to 7 plus 3 over negative 1/3. 3 divided by negative 1/3 would be the same thing as 3 times negative 1/3, or 7 minus negative 9. 7 minus 9 is also negative 2. So our left side equals our right side. Therefore, this is our solution. X is equal to negative 1/3. Oh, and yep, good. Now let's look at this next question. Remember that if our equation consists of a single rational expression on each side, so there's only one rational expression over here and one on this side, then we can use cross multiplication in order to solve. Okay, but first, before we do that, let's state our restrictions. X cannot equal negative 1 or negative 2. Okay, so since those can't equal, that's good. Now let's cross multiply, since there's only one rational expression on each side. So once we do that, I'm going to be left with 5x plus 2, and that is equal to 2x plus 1. Let's distribute that 5. Well, we have 5x plus 10 is equal to 2x plus 2. If I bring this 2 over the other side, I have to subtract it from this side. Minus 2x, which gives me 3x plus 10 is equal to 2. I'll have to bring this 10 over the other side, subtract 10 from both sides. It's going to give me 3x is equal to negative 8. And I need to divide by 3 on both sides. Divide by 3. X is going to equal to negative 8 over 3. And finally, again, x cannot equal negative 1 or negative 2, which was stated by our restrictions right up here. And so what we need to do is verify whether or not this solution is actually going to work. Okay, so verify. So let's start with our left side is equal to 5 over negative 8 over 3 plus 1 would be 5. Negative 8 over 3 plus 1. Negative 5 over 3. And that's equal to 15. negative 15, negative 3. And our right side, let's see what our right side equals. Right side is equal to 2 over negative 8 over 3 plus 2. We're going to end up with 2 over negative 2/3, and that is also going to equal negative 3. Therefore, our left side is equal to our right side. Good. So that all checks out as well. Now, we have some more questions. We're going to solve this the exact same way we did the last one, where we have to cross multiply both our terms, but you'll see here that once we cross multiply, we're going to be left with a quadratic equation, right? And over here, this is going to be a long one, but yeah, let's do both of them. Well, yeah, I'll do both of them. So first thing, let's list our restrictions. X cannot equal negative 3 over 2 from this guy, or negative 5 over 3 from this guy. Remember, if we have only one rational expression on each side of our equation, then we can just cross multiply. So that's what I'm going to do here, is cross multiply this term and this term and this term and this term. So I'm going to be left with 4x minus 2 times 3x plus 5, and that is equal to 2x plus 3 times 6x minus 1. When I expand this, I'm going to use my distributive method on both sides. And once I do that, I'm going to be left with 12x squared plus 14x minus 10 over here. And then over here, I'm going to be left with 12x squared plus 16x minus 3. Now, what I need to do is gather my like terms. If I bring my x's to this side, 12x squared, get rid of this 12x over here by subtracting it, would give me 0 with my x squareds. If I have 14x and I have 16x on this side, if I bring this x over here, I'll be left with negative 2x. And then if I bring everything else over here, if I have negative 3 and I add 10 to here, I'll have 7. So 7 divided by negative 2, x is going to be negative 7 over 2. Now we have to verify and make sure that is our solution. So verify, left side is equal to 4 times negative 7 over 2 minus 2 over 2 negative 7 over 2 plus 3. So let's see what that's going to come out to. If I have 4 times negative 7 over 2 minus 2 divided by 2, or 2 negative 7 over 2 plus 3, negative 6, that's going to be 4. That is equal to 4. Now let's see our right side. Right side was 6 times negative 7 over 2 minus 1 divided by 3 times negative 7 2 plus 5. 6 negative 7 over 2 minus 1 is equal to negative 22. And let's see here, negative 22 over 3 times negative 7 over 2 plus 5. It's negative 5.5. Negative 22 divided by negative 5.5 equals 4. Good. So our left side equals our right side, therefore that's our solution. Okay, I'm going to, Okay, yeah, I'll do this one. I'll do both of these. 5t minus 2 divided by t plus 1 minus 2t minus 1 divided by t minus 3 is equal to 3. Now let's state our restrictions. T cannot equal negative 1 or positive 3. Now I have to multiply by my least common denominator here, or my lowest common multiple of my denominators. Okay, so that is going to be here t plus 1, t minus 3. So both sides I'm gonna multiply by those numbers. So I'm going to do this the long way this time. If I have 5t minus 2 over t plus 1 minus 2t minus 1 divided by t minus 3 equal to 3, and if my lowest common denominator is t plus 1 times t minus 3, then what I need to do is multiply the top and bottom by that. T plus 1, t minus 3, and then I have to multiply this side by that, t plus 1, t minus 3. Okay, now the nice thing here is that we're going to cancel out what we have on the bottom, and I have to do it to this equation separately, so that's going to be t plus 1, t minus 3, and that'll cancel out there. And so what I'm left with is this term subtracting this term, and nothing on the bottom, which is nice. So I'm going to have t minus 3 times 5t minus 2 minus 2t minus 1 t plus 1, and that's going to equal 3t plus 1 t minus 3. So this is going to be a pretty big equation here. Now the next thing we got to do is use our distributive methods in order to solve what this is going to be as a quadratic, like that. And so I'm going to be left with 5t squared minus 5t squared 2t minus 17t plus 6, and I'm going to subtract what I have here, which is 2t squared plus t 2t squared plus t minus 1, and that's going to equal 3t squared minus 6t 3 minus 3 minus 9. Okay, so from here we're going to simplify. I'm going to have 5t squared minus 7t plus 6, and I'll get rid of this bracket now. Once I get rid of the bracket, I'll have 2t squared minus t, negative and negative is going to be plus 1, equals 3t squared minus 6t minus 9. Okay, so let's add up our common multiples. 5t negative 2t is going to be 3t squared. 7t and t is going to be negative 18t plus 1, and plus 6, and plus 1 is going to be plus 7. And yep, we're good here, and we have 3t squared minus 6t minus 9, not plus. Minus 9. Okay, now the next thing we gotta do is put our like terms together. So if I subtract negative 3t squared here, I gotta do it on this side, which would cancel that out, leaving me with negative 18t plus 7 is equal to not that, negative 6t minus 9. If I add t to this, add 6t over here, I'm going to add 60 to that, which is negative 12t plus 7 is equal to negative 9. If I subtract 7 from this side, over here I'll leave negative 12t is equal to negative 16. Divide both sides by 12. T is going to be equal to 16 over 12, or divide those both by 4 4/3. And let's see here, we do need to verify this, and so let's plug 4/3 back into our original equation. Now, just for the sake of saving time, I'm just going to plug it straight into my calculation here. So 5 times 4, or 4 divided by 3, minus 2 divided by 4 divided by 3 plus 1. So that equals 2. Oh, this actually equals 2. So the right side actually equals 3, and that equals 2. So this is not actually a solution. Oh, sorry, I only did this part, 2. Yeah, no, don't listen to that. I now need to plug this side in. So 2 times 4 divided by 3 minus 1 divided by 4 divided by 3 minus 3. And hold on a sec, I don't think that was 2 times 4 divided by 3 minus 2. And then we divide this by 4 divided by 3 minus 3. It's negative 0.4. Something's here. One more time. I'm going to go 4 divided by 3. I'm going to store this. 2 times alpha A minus 1 divided by alpha A minus 3. There we go, negative 1. So 2 subtract negative 1 would be 2 plus 1, and that would be 3. So then left side is equal to our right side. So it checks out. Okay, so for this last one, just so this video doesn't take too much time, what you want to do is you'll find that your restrictions are going to be that x cannot equal plus or minus 4. Okay, I'm not going to do this whole question, but I know that this is something you can do yourself. I'm just going to kind of guide you through it right now. But the first thing you need to do is notice that this is a difference of squares here. And so if you rewrite this equation, you're going to have 1 over x minus 4 plus 2 over x plus 4 is equal to 5 over x minus 4, x plus 4. And now from here, what you need to do is, well, since you don't have equal sides, you're going to have to multiply both sides by x minus 4, x plus 4, and then see what's going to cancel out. All right, good luck.